Howdy once again, it's Tubalcain, your YouTube shop teacher. Now this is video tips number 489 entitled Converting Your Delta 14-inch wood cutting bandsaw to a metal cutting saw by the gear motor method. My continuing with this series was contingent on the success of the first video with this method using the pull gear, and it was highly successful, just beyond my my dreams. I do not need to really do this for myself because I have the Boyce Crane metal cutting saw, but thousands of people have these wood cutting saws that are useless for cutting steel but can be converted by these three methods. So probably no one will be able to do this because there's only three pull gear speed reducers known left to mankind. However, this particular conversion would work in other saws with the base. In other words, there's plenty of room down there for that. Probably not for the video I'm going to show you right now, or start right now, because this is a gear right angle drive type motor, and it's rather long and it would not fit in a cabinet like this, perhaps an open cabinet, but nevertheless I'm going to go ahead with this. Now you're probably saying, I don't have one of these either. And this came from a garage sale. It was $5, and some man had it hooked up to a jury-rigged can crusher, beer can crusher. So I bought it for $5, threw away, that's 5 years ago, threw away the can crusher and thought, well, I'll have use for this sooner or later. Now that's a 1/6 horse motor, 1725 RPM, and it reduces it with the gear right angle drive here. And now that's a worm gear in there, and that's 36 RPM. So I think that's going to be just the speed I want, and I can adjust that a little bit one way or another by changing the pulley on this unit as well as the pulley here. And of course I'm not going to use this great big 12-inch pulley because that would reduce it way too much. No, you can't go out and buy one of these new. I would suspect that's a $500 unit. I'm not really sure, but this is Boston Gear, the highest of quality, and the gears run in oil. This unit runs very quietly at 36 RPM. I got it running just to show you. Now let me go ahead and start up the bandsaw. Now this sounds like a threshing machine. I lucked out in that this unit is already running in the correct rotation. Now it's possible that it could be reversed. I didn't bother to check, but if it isn't easily reversible by just opening up the cover and changing some leads, it could be done by somebody that understands motors, and it might be an internal thing that you would have to do, or a motor shop, but they can be reversed even if it doesn't appear to be obvious. This is a 110 volt single phase motor. The gearbox label does not tell the ratio, but you can figure out the ratio. Well, the ratio is 36 to 1725 or 1750, whichever it is. So that's the ratio, and that's a considerable gear reduction. And did I say this is a worm gear, and you need a worm gear to reduce the speed in a very compact unit like that. If they're spur gears, it's going to be a much larger, more complicated unit, and possibly with several gears. The way it is inside of here, and I'm not going to take this apart, there is simply a worm and a worm gear. Here's another right angle gear drive without a motor. And this particular one I wrote on the bottom is a 20-to-1 ratio. Notice that there is an input on either side, so it would be easy to reverse the direction by that method. That's the input. Or the motor would be reversible. So this unit could also be used, and I have a bunch of these. Like I say, they're a dime a dozen. I bought 6 of them recently for $1 a piece. And I don't know if I haven't even examined them because I don't really need to, but these can be connected to an electric motor either by a pulley or direct motor input using a Lovejoy type of coupling, if you know what I mean. Now, I know what many of you are going to say, well, I don't have a motor, I don't have one of these, and this wouldn't be cheap. If you had to go out and buy that, I don't know what it would be, but it would be hundreds of dollars, but there's probably a lot of them on the internet. The only thing is, if you set one of these up along with an electric motor, it takes up quite a bit of room, probably more than this unit. So if there would be enough interest, I would make yet a fourth video on this, possibly setting this up on the Delta bandsaw as well. Now, I know I've talked a lot here on the introduction, but I'm always trying to give people other possibilities and different ways of doing things without going to the jack shaft type of unit, which I will show you right now. It was shown in the last video, but let me show that again since it's right here on the bench. If you watched my last video, you know that Tom Chris sent me this article while I was in the middle of making the video on a speed reducer, and this was, if you want to look it up, Popular Mechanics, February 1969. There were a lot of different versions, but as I told you, this takes up a lot of room, and it requires a total of 4 pulleys and 2 belts. And this particular application here is a double-ended shaft motor. That is, this motor has a shaft coming out of both ends. There probably would be a lot of different ways of doing it, but in examining this picture very closely, I can see that this is the bottom casting of a Delta saw, so I found that a little bit interesting. I don't think I mentioned that in the last video. Let's get to work. You need to refer to the previous video to see what the original setup here was from Delta with the 2 different pulleys and the guard and everything on there. But in this video, the first thing I'm going to do, and I won't show this, I'm going to take the gear, the pull gear off, and that belongs on my drill press, so it'll go back on that eventually. This has to come off, and this big pulley that I just bought will come off. And then I'm going to mount this. This will be a simple setup compared to the other one. I'm going to mount this unit right here. Now I'll have to take this motor off and get it out of the way, and I'm sure that I will have to drill some holes, but if possible I'm simply going to clamp this on here, but I'm not sure I can clamp it. And then I will play around with pulleys and different ratios. This is a 3.5 inch pulley, and if anything I will probably have to put a smaller pulley here than this 4-incher. But I'm going to play around here, and I'm working for getting a speed here on the bandsaw of a cutting speed of anywhere between 150 and 300. Now I realize after the last video that I do not have to get it down to 100 feet per minute, but it can be considerably up from that and still be quite successful. And I do have a metal cutting blade mounted on this saw if you watched the last video. So the next time you see me, I will have this off and at least have this set in place and decide what I have to do in terms of pulleys and belts. But I think we'll take a little field trip out to my garage right now and show you some other gearboxes that I have, just to show you, what is available. And you will be able to find those, of course, in McMaster-Carr and Granger's and other industrial catalogs. But if you're interested in doing this, probably eBay or Craigslist. I'm in the garage and I have 3 different gearboxes here, and I just acquired these. You probably saw it in a recent auction where I bought all of those motor controls. These were like $1 or $2. They had many more, and I thought some of them were dripping with oil, and I didn't want to load them. This is made by Boston, and Boston doesn't always tell the ratio. I don't understand that. Now, it's easy enough to figure it out if I want to take the time, but I'm not in the mood during this video. But they talk about input torque and output torque and things like that. So. And I don't care about that, but anyway, there's a possibility. That's kind of a big, heavy one, but it is Boston. Look at the size of that shaft. Now here's another Boston, and Well, you can see that these are set up, well, the first one with a sprocket on one side. And maybe these are worn out, but I'm sure they would work for what I'm talking about. Okay, here too, we got a sprocket and we got a variable pitch pulley. And this is Boston gear, and it does tell the ratio here that is 40 to 1. Reminds me, maybe a fellow could make a dividing head out of that if he had a notion. I don't. And then finally here is a little gearbox. Again, it doesn't tell. This is made in France, so I have to ask Pierre when he comes. I can't read the label, and somebody vibrated some information, you know, with a vibrating pencil over the label, and it's absolutely not legible. But that's a nice compact little one that would be very usable. This is the input, this is the output. So naturally you can see that the worm is on this shaft and the worm gear on the other one. And this type of gearbox always changes the direction by 90 degrees. Reminds me of a Fordson tractor. You know, those were a worm drive. They said the operator sitting on the seat got so hot from the friction he could hardly stand to be on that metal seat. So there's a lot of friction here, which means that they are inefficient, I suppose. I'm not an engineer, but that's just what I read. All right, now back down to the basement and what this video is really all about. I got a bit sidetracked, as it is my wont to do. All right, 3 hours has passed, and well, I went someplace, so I wasn't all involved in working here, but I did waste quite a bit of time. And I do have it running right now, but a good part of my time, even though I have hundreds of V-belts, was spent pawing through those V-belts, and I never did have any belts that were in the 38, 39-inch category. So to overcome that shortage, and I got a lot of duplicates of some, so that's kind of a pain. I should throw some of them out or put them on eBay. But let me talk about the speed now. Now I have the motor and gearbox mounted temporarily. There is one hole, one bolt, so it's not going anyplace. It just happened to fit. And vice grip on the other side. Now notice that I have a 3.5-inch pulley on the gearbox. Remember, that's 36 RPM. And I put a smaller one on the bandsaw shaft. I had trouble finding small ones that have a 3/4 bore, and it needs to be a small one. Why a small one? Well, in order to, in fact, speed it up a little bit. Now I'm doing just the opposite of the previous video where I was trying to slow it down. Now I'm trying to speed it up a little bit because 36 RPM is actually too blame slow. So my tachometer will not work again at that slow a speed, so I did count down, and just the old-fashioned way with my Folex watch, and came up with, let me show you. So the RPM there was 62, and that comes out to 250 feet per minute. Now I didn't bother calculating that because I'm sick of doing math. I don't think anybody wants to see me do that anyway. So I did indeed put the tachometer with the wheel right on the blade and came up with that 250 feet per minute, which, you know, I'm not going to fiddle around anymore. That's just almost an ideal speed. Originally I wanted to be down to 100, and in order to get it any lower, and I don't intend to, because now I know that 250 feet per minute is a pretty good speed, but in order to get it lower, I would have to use a larger pulley here and probably keep that size on there. The problem with the small pulley, there's not that much wrap, and as you know, if you know anything about mechanical transmission, that there's a good chance of a belt slipping when you don't have much wrap. And that's just a standard A belt, 1/2 inch wide. It's not a cog belt or anything like that. A chain would work on those too, by the way. If you had sprockets, then it wouldn't slip. And the sprockets are pretty easy and fairly cheap to come by at farm stores. Yes, I'm talking too much because I'm just trying to give you all kinds of different ideas and information here. But notice how, well, this is a larger footprint. That is, the motor sticks out, well, by what, 10 inches. So now it's bigger than ever. So would this type of gearbox work on your saw? Could that gearbox be mounted vertically inside of this cabinet? It definitely would fit and definitely would work. The problem is the oil. Would it leak oil in that position? That is, with the motor down toward the floor and the gearbox up. But there's just plenty of room in there for that type of application if oil leakage was not a problem. And I do not know. I'll let you decide that if anybody is going to go that route. But boy, I see this as just a wonderful way to reduce the speed to metal cutting. So now I got really an ideal speed. So I'm not going to play around with any other belts or pulleys. And I came up with all different ones here. I had a little trouble finding 3/4 inch bore. I guess I said that. And no, I do not intend to mount this temporarily because this is just a experiment for your sake, in fact. Now I'm still tethered to this motor because the cord goes into a switch, and I didn't really feel like taking all of that off because I'm going to put this back into the original woodworking position here when I'm done after the next video or two. But this is what it looks like from the backside. It would be relatively easy to make a guard for the belt, maybe even adapt the one that I already have. I'm not sure, but you definitely would want to guard that belt because that'll chew your finger right off. I do know several men that had lost fingers in belts. It'll take them right off. So don't mess around, don't play around, and you certainly don't want this where some child like Henry might walk behind the saw as I'm working on it and touch that. And bam, that would take your whole hand, a child's hand off for that matter. So you can't be safe enough around belts, pulleys, gears, chains, and sprockets. I think you'll all agree with me on that. You know what? I think I will show you the speed. It's interesting. If you've never seen a tachometer like this, it will take a direct reading with the wheel in feet per minute, and that is the red scale on the inside there. So you can see it's between 20 and 30, but we have to add a 0 on there, so instead of it being 25, it is 250 feet per minute blade speed. Alright, I've got quite a mess here, but I'm going to go ahead off camera and turn the saw 180 degrees, and we'll take some sample cuts to see how this cuts, and will this belt slip on that small pulley. That is really the only question. Other than that, I know it's going to saw just fine. I had the saw turned around, took a cut, and it was a total abject failure in some ways as I predicted. And what happened? The belt slipped on the small pulley. Why? Because there's no wrap there. Also, the first thing I will do is to attempt to tighten this a little bit more. But you know, these old belts, and that is quite loose. So I'm going to tighten it up, which is kind of hard to do, but I'll use a pry bar and pry in there. But those old belts have lost their suppleness, if you know what I mean. They're relatively stiff, so I will put a pry bar in there and attempt to put a lot more pressure on there. But let me show you what happened. You know, I'll just keep the camera right on that shaft. Well, let me turn it off and then back on, and then I'm going to take a cut and watch that slip. Alright, watch. You can see the belt is too loose, so matter of fact, it's too loose, the trick. Let me tighten it up and see what happens. I'll see you in 5 minutes. Alright, I tighten it up. It's tighter than a drum. Any tighter than that, you know, it's really hard on bearings. So watch it now. Oh, it sure doesn't look tight. You see the belt want to ride up and over? Unless I just loosened a little bit. Let me try one more time. And I'm not going to bother with putting dressing on there. I just don't think that'll do the job. Here's a pop quiz for you. What is an expert? Well, the answer is an expert is someone that's more than 50 miles from home. Now remember, I'm not an expert at all. I'm just 50 miles from your house. I'm not any smarter than you or any of my viewers. But here's what I'm going to do now. I definitely have to have a larger pulley here so that it won't slip. But if I put a larger one, this is the original 4-inch. If I put that on there, that's larger than this one, or about the same. Yeah, it's larger. This is 3.5. So what will happen there now is I'm going to slow it down even more. I'll be down to 30 RPM at this point. And I never really dreamed that I would want to speed it up, because all I have harangued about in my videos is get that speed down for metal cutting. Well, now I'm quite the reverse. I want it just a little bit faster. So in order to achieve that, and this will take me an hour and then I'll be back, I think I'll put the 4-incher on the main shaft, and then I need, that's a 3/4, these are both 3/4 shafts. I do not have that many pulleys in 3/4, but I do have this big step pulley, so I can play around, put that on this if it'll fit. That's a question, will it fit? And I might even have it on backwards like that. So I have a choice here of a 3, 4, 5, and 6. So I would like to possibly use the 5 here and the 4 there, if I can find a belt. I told you I'm having a lot of trouble finding belts, but that's going to be a longer belt, and I have a lot of belts in the longer sizes, just that I have to go into that hot attic. Now it's quite hot again today, and dig around. I should have brought that whole box down here, but that was too big a chore. All right, I will see you in 1 hour. It's 45 minutes later, and I'm so sick of rooting through V-belts. I should quit for the day. But notice several changes. Now, first of all, in order to accommodate this 6-inch pulley here, I had to mount the whole unit here on a 3/4 inch board. No big deal. But I now have it held and clamped in with 2 vice grips and 1 bolt. And since that's a 4-inch pulley, you can't quite see it there where the yardstick is, and it's a 4-inch pulley here, we have no reduction at all. So this is running at 36 RPM, which is almost exactly 100 feet per minute. Isn't it funny that that was my target in the last video, but now it seems so slow. But I think I'll go ahead and cut a few pieces and see if that's satisfactory. If not, what I need to do here is to move this unit over and use the large groove here and this, but it'll take a longer belt, and try that out. But let's see first of all if this belt is going to slip on either one of the shoes. I'm cutting 1/4 inch steel. You can't see it, but I'll put quite a load on it. See what it looks like. Watch those belts. Well, I cut that apart. That wasn't much, but you can see that there was no belt slippage, so that's pretty good. Take a look at the setup in this direction. And if it was a setup that I wanted to complete, what I would do is drill 4 holes to mount this unit. And I would have to keep that piece of wood under there. It galls me to use wood, and that's going to get oil soaked and ugly. I just don't like using wood. If this was a permanent situation, I'd use either a steel or aluminum plate under there. Otherwise, I'd be ashamed of it. In case you have not watched the last video, this is a metal cutting blade bought from KBC Tools, and it's a Starrett 3/8 wide, 25 thick, 14 teeth per inch, and regular set. Let me cut through some 1/8 inch steel here and let's see what happens. I tightened the belt up as tight as I possibly could get it. no stalling. I was pressing quite hard. Now it's cutting slow because the speed is so slow. So let me try some 1/4 inch stock. This is 1/4 inch. This is 3/4 thick steel. I was able to stall it, and it's cutting so slowly at 100 feet per minute. You know, even though that was my goal, I'm not satisfied. I will see if I can speed this up just a little bit. This is my final setup. I'm on the 5-inch pulley here. That's the 4-inch pulley. It's a 43-inch belt. This was the easiest setup I made. That only took me a couple minutes. I must be getting good. But that gives me 45 RPM on the main shaft, just like an old record, and about 170 feet per minute of blade passing through the work. That almost seems like an ideal size. And with these larger pulleys here, I just feel that there's less chance of belt slippage. Now there's some point where the blade may slip on the tires on the bandsaw wheel, because those are 40-year-old tires that are relatively hard probably, but you know, that can happen. I'm not saying that it will or did. Let's saw some metal. You know what? This motor is fairly warm. I mean, I can hang on to it, but I'm just wondering why it's that warm, considering that I haven't really done that much cutting. But looking at the meter here, well, it's really only 114 degrees. That's Fahrenheit. All right, back to the business at hand. Remember, that's our speed. This is aluminum. I was able to stall it. I'm not happy. 1/4 inch steel. Now the belt is slipping. I looked back there as I did that. It's slipping on the 4-inch shiny pulley that's on the main shaft. That pulley is the original pulley, and it just seems like it's not gripping. Now I put some belt dressing on there. That did not help one bit. So I have to quit for the day in discouragement. So I'll see you tomorrow, and I'm going to try to find a larger pulley. I might have to buy one to put onto that main shaft. I'm thinking something like 6-inch. I'll see you then. See you tomorrow. I'll be all right. Welcome back. It's a new day, and I'm in a little bit better mood. So I've changed the pulleys now. Remember, I'm still suffering from belt slippage. So I've got a 5-inch pulley here and a 5-inch pulley here. So really that's a 1-to-1. So the RPM is 36. The feet per minute is 130. And I'm still having trouble. By the way, this pulley is badly bent because it's used. A little slower than I want, and I'm having a heck of a time here getting the belt tight enough. I just don't have a good place here for leverage, and there are no slots. Remember, I'm using clamps here, so it's quite cumbersome because this is just a temporary setup. So I'll do a little cutting, but I expect it to be slipping. What I have finally determined that I need to do here probably is use the 6-inch pulley here, and I would like to have about a 10-inch pulley here, but I'm not going to buy another one. But I might put that 12-inch pulley on if I have belts long enough to accommodate that. So let me do a little cutting at this speed, and that, you know, really that may be enough for this video. I expected when I started this video it to be a very short video, 5 minutes, because there's just nothing to it. But it has turned out to be the longest one. that is 1/4 inch steel, and it did cut it. I stalled it, or not stalled it, the belt slipped once there, so I had to go a little bit easier, but that means it's certainly going to slip on thicker metal, but it probably is okay. You know, even my other Boyce Crane bandsaw, I sometimes have to baby on thick metal. I know this looks outrageous, but it isn't. I'm about done with this video. But now with that 36 RPM on the gearbox and a 12-inch pulley and a 6-inch pulley, that gives me 72 RPM or 275 cutting feet per minute, and that's about where I wanted to be. And this has been a struggle, and I tell you, it sure does help when you have a lot of belts. And like, yeah, I got consecutive ones, 56, 58, 57, and the 55 is what I got on there, but at least it doesn't slip. And the whole idea here is that now I have 2 large pulleys with plenty of wrap, and there isn't the tendency to slip. I do think that my very new old stock ancient V-belts have lost their gripping power, although I may be imagining that, I'm not real sure. Let me know in the comments if you think that could be the case. So now I'll turn the machine around and make just a couple cuts and conclude the video. So yeah, this is outrageous. It takes up a lot of space. It would be hard to put a guard on there, and there's just absolutely no way that this monstrosity would fit inside of that cabinet. So the video that I thought would be the easiest, and the job of setting this up would be easy. It's not. I spent a lot of time on this, and well, it is an experiment, but also to give options to people out in YouTube land. Again, there's the speeds. Pay no attention to this. That's from earlier. This is, again, 1/8 inch steel. Not the fastest, and I was able to stall it just a little bit there. Did you notice that? Or cause a slip. But again, I told you I do that on my Boyce Crane, and we just have to remember, I guess, that this is not a do-all. This is not a Grove. This is just a wood-cutting, inexpensive bandsaw, really not built to do this job. 1/4 inch hot roll steel. Wear your safety glasses. Now, do you know what? I really am going to discourage the use of this. I thought this would just be the best thing since sliced bread. But in using one of these for the setup, there would be 2 belts involved. And with 2 belts, especially with these smaller pulleys, there's just 4 pulleys on which 2 belts could possibly slip. And unless you use bicycle chain and sprockets and all that, I just don't think this would work. And it would take up too much room. Unless, even if the motor was mounted directly here with a Lovejoy coupling, you got kind of a bulky outfit. That would eliminate 1 belt, though, if the motor went right into here. But of course the height isn't going to be right, so it would have to be built up. So I think I was delusional in suggesting that earlier, using a right angle drive gearbox for this application. So forget that. Now in the next video, the follow-up video, I'll be installing the DC motor and control on this saw. And now I don't have such high hopes for this, because now I'm back to using belts and pulleys and all that, and I just wonder if, first of all, that will have the torque needed. But this whole job wasn't quite as easy as I thought it would be, and so far it looked like the pull gear was the best option. But we'll see in the next video. Well, this concludes an incredibly long video to show you how to use this right angle drive motor to slow down and convert a Rockwell Delta 14-inch wood cutting bandsaw into a metal cutting saw. Hope you liked it. Hope you learned something. You know, I learned a lot on this video. Matter of fact, I bet any money that I learned more by making this video than what you will learn by watching it. If you like my videos, give me a thumbs up, and I'll see you in that next one. And be sure and watch the last one as well.